Hello dear students, I am Professor Mandar Dixit from Electrical Engineering Department. Today we will see the concept of supernode. In case of an electrical network, when a voltage source is present between a pair of nodes, then we consider it as a supernode. Let us draw it by a circuit. Here in this circuit, there are two nodes A and B which are further connected with some resistances. In between A and B, there is a voltage source. So, if a voltage source is present in between any two pair of nodes, then it will be considered as supernode. So, this A and B will be considered as supernode. When you find such kind of connection in a circuit and when you have to solve the problem with the help of node analysis method, then supernode concept can be used for problem solving. In supernode numerical, similar to supermesh, the two equations will be written and the remaining equations will be for remaining nodes which are not supernode. To understand this, let us solve some numericals based on supernode. The numerical which I have taken for solving the supernode is find the node voltage V2 by using nodal analysis. This is my circuit. If you observe the circuit, this is V1, that is node 1, and this is V2, that is node 2. In between V1 and V2, there is a battery or a source having voltage 10 volt. Hence, this V1 and V2 will be considered as supernode. Let us redraw the circuit by assuming currents in each branch. Let us mark this node as V1. Let us mark this node as 2 and this common node as 3, which is reference node. Voltage at node 1 is given V1, voltage at node 2 is given as V2. Then draw the unknown currents. Now in this circuit, because 10 volt is connected between V1 and V2, this will be considered as supernode. For supernode, for supernode 1 and 2, as the end of V1 is connected to positive terminal of 10 volt and end of V2 is connected to negative terminal of 10 volt. Hence, the V1 will be at higher potential and V2 will be at lower potential. Also, this indicates that the potential difference between 1 and 2 nodes is 10 volt. Hence, by this conclusion, we can write down the equation for supernode as V1 minus V2 is equal to 10, which is our equation number 1. The other equation will be for same supernode excluding this 10 volt branch. Apply KCL at supernode. Then our incoming current for node 1 and node 2 is 5 ampere, and outgoing currents from node 1, node 2 combined are I1, I2 and I3. Hence, sum of incoming current is 5 ampere and sum of outgoing current is I1, I2, I3. As no current is indicated for this element because the potential difference between 1 and 2 is 10 volt, hence no current will be considered for 10 volt battery. Remaining currents are I1, I2 and I3, which are outgoing currents for combined node as supernode. Hence, we can write down the equation as I1 plus I2 plus I3 is equal to 5, where I1 plus I2 plus I3 is outgoing current and 5 ampere is incoming current. By Ohm's law, I can write down I1 as I1 is the current flowing from node 1, supernode 1 to reference node. Hence, it is written as V1 minus 0 divided by 2. Similarly, I2 is flowing from node 2 to node 3. There is a 5 volt battery connected between node 2 and node 3. Hence, I2 is flowing like from node 2 to source 5 volt, from source 5 volt to reference node. Hence, I2 can be written by Ohm's law as V2 minus 5 minus 0 divided by 3. And I3 is similar flowing as I2. I3 is also flowing from node 2 to battery or source 20 volt to reference node. Hence, I3 will be written as V2 minus 20 minus 0 divided by 2. In both all cases, 0 is the potential assumed for reference node. Substituting all values, we get V1 minus 0 by 2 plus V2 minus 5 by 3 plus V2 minus 20 by 2 is equal to 5, where V1 minus 0 by 2 is I1, V2 minus 5 by 3 is I2 and V2 minus 20 by 2 is I3, which is equal to 5, that is our incoming current 5 ampere. After solving, we get three V1 plus 5 V2 is equal to 100, which is equation number 2. For supernode, we get two equations. One equation is for supernode element, that is V1 minus V2 is equal to 10. Second equation is the equation of supernode excluding the supernode element, that is 3V1 plus 5V2 is equal to 100. Solving equation number 1 and equation number 2, we get V2 is equal to 8.75 volt, which is the answer of the problem.